Assalamu alaikum everyone, I am Sharjeel and in this video tutorial we will see how to solve a quadratic equation using completing the square method but with step-by-step technique. So the equation here to solve we have our quadratic equation, and the first thing we're gonna go ahead and make sure that the variable part of our quadratic equation should only be the part that is on the left hand side, and for that we will add 15 on both sides of our quadratic equation, and by adding 15 we will have 3x square minus 15 3x square plus 4x minus 15 plus 15 equals 0 plus 15. This is the quadratic equation. This is the equation we have by adding 15 on the both sides of our equation. Now what will happen? These two 15s will cancel out each other and we will have 15 equals 3x square plus 4x. Now what will we do? We will look at the coefficient of x square here, and x square should have 1 as a leading coefficient of our quadratic equation, and so for that we will divide our whole the equation with 3. So by dividing our whole the equation with 3 we will have x square plus 4 upon 3x equals 15 upon 3, which further will be 5. 3 will cancel out, 3 and 15 will cancel out each other, and we will have 5 here. Now this was our second step. Now what will be our third step? Our third step will be to look at the coefficient of x here, which is 3. Now writing it here, 4 upon 3, we need half of our 4 upon 3, the coefficient of x, and for taking its half we will multiply it with 1 upon 2. Now we will have 2 upon 3. 2 upon 3, yes, here we have 2 upon 3, and we will take the square of it. Now we have 2 upon 3 the whole square. The term we will add on the both sides of our quadratic equation, which is our third step, and we will have x square plus 4 upon 3 x plus 2 upon 3 the whole square equals 5 plus 2 upon 3 the whole square. So here what we did, we took the coefficient of x with degree 1 and we took half of it. And take the square of our term, and then we add that term to both sides of our quadratic equation, and now we have these three terms which can be written as x square plus 2 times x times 2 upon 3 plus 2 upon 3 the whole square equals, these two terms can be written like 49 upon 9. And now these three terms tell us that it is a perfect square of x plus 2 upon 3 the whole square. Which identity did we use here? The identity we use here is a plus b the whole square equals a square plus 2ab plus b square. So now what will we do? Here we have x plus 2 upon 3 the whole square equals 49 upon 9, and this was our third step, in which we add this term on the both sides of our quadratic equation, which was the half of our coefficient of x with degree 1, and then we take the square of that term. Now what will be our final and the fourth step? We will get rid of this square here, and for getting rid of this square here we will take the square root on the both sides of our quadratic equation, and by taking square root on the both sides of our quadratic equation we will have x plus 2 the whole square with under root and 49 upon 9. So here it will cancel out each other, and we will have x plus 2 upon 3 equals, these two terms can be written like 7 can be written like 7 the whole square upon 3 the whole square. So here we will write these two terms as 7 the whole square upon 3 the whole square. And now these two squares will cancel out the root, and we will have 7 upon 3 here. And now by transposing this term to the another side of equation, we will have x equals plus minus 7 upon 3 minus 2 upon 3. We have two roots of our quadratic equation in this form, which can be written like x equals, either the value of x equals 7 upon 3 minus 2 upon 3, or it equals minus 7 upon 3 minus 2 upon 3. This will give us 5. These terms will give us 5 upon 3, and here it will give us x equals to minus 3. So we get our roots with this method, with completing the square method, but today we get these roots with step-by-step technique. So here was the step-by-step technique of completing the square. In next video we will show how to prove quadratic formula with using general form of our quadratic equation, and in further videos we will also see that how can we use quadratic formula in solving our quadratic equations. Till then, thank you. Allah Hafiz.